Welcome you to lab number 2 here. Today this video is about lab number 2 on control system. So the basic idea this lab is to familiarize the student with how to solve the block diagram reduction using the Matlab commands. So before going in block diagram, it's better just go through about the block diagram in general. So normally what we do have we want block diagram reduction so that we can represent input and output relation directly represented by a transfer function. So before doing this, so there are four components that are involved in reduction. First one is the signal that is represented by arrowhead, so R of S and C of S, and there's a block that is represented by the transfer function of the system. Okay, so this block contains the transfer function that has input R of S and output C of S. The third one is a summation junction here, where you have different inputs that are add up and subtract, and after this junction you get this type of result. So similarly, the fourth one is the pickup point, where you can divide your input into different different branches. So it is known as pickup point. Now let's see an example here. So this is a block diagram with input R of S and C of S is the output, and there is a feedback dynamics that is represented by H of S, and you have a controller dynamics that is represented by G1 of S, and system or plant is dynamics G2 with the disturbances as the input. So from here, if you look at, if I start from RS to CS is known as forward path. If I go back from the output to the this junction is known as feedback path. So here if I take the transfer function, I just multiply G1 G2, I get the direct transfer function or feed forward transfer function. And for open loop for feedback transfer function, we have only HFS. So for open loop transfer function, what we have to do, we have disconnect this branch and calculate the transfer function. Means that I have to multiply G1 by G2, and then H is known as open loop transfer function. And similarly, for closed loop, I have to take the ratio of CS to R of S. So we will see how we calculate the closed loop transfer. So there are some definitions that we will know before solving. First one is the GFS represented in this block diagram as the forward transfer function, HFS as the feedback transfer. For open loop, you have to cut this branch and calculate it. So in that case, you have to multiply these two, is known as open loop transfer function. Similarly, for closed loop, you have to take the ratio of CFS to the RFS and you calculate the transfer function. Similarly, you have feed forward transfer function, you have to take the ratio of E to C and it's known as feed forward transfer function. Here you have only G of S here. Now for a feedback transfer function, how you calculate it? Very simple. First of all, you have to write the feed forward transfer function, that is transfer function between R and C, that is G of S. Now after that, you have to put a line, and in denominator you put 1 plus G times the what you say open loop transfer function, that is multiplication of G and H put in here. If here is the minus, you have to put plus here. So this is the way you can find the feedback transfer function. Now in block diagram, there are different blocks are connected in series or in cascade, known as series connection or cascaded connection. How you reduce these blocks? You just need to multiply these, and look here, this is the reduction of these three, that in that case you have just multiplied it. Similarly, in parallel case, you have a single input, and that input is multiplied with 3 transfer function in parallel, and it is add up. How you solve it? You just add these transfer function. So this is the reduction of these block diagram. Now after that, so there are some algebra that can help you to solve the problem. Look here, if you have an input with a summation, after that you have a block. If you want to make this block to the back, then in that case you have to multiply before summation on both x and y, so that your algebra is remain the same. So look here, you get the same result. Similarly, in the next one, if you have a block here and you want to move it in on the front of submission, in that case you, when you move it, you have to make the division here so that the output is remain the same. Look here. So this means that you can do manipulation, but the main idea is your output must be remain the same in algebraic relation. So for example, there's another one. If you have a two inputs without a g of s and one input is with g of s, if you want to take it to before of this, in that case you don't need anything here, but here you need division. So look here, to make the relation same, you have to divide here in these two branches. Similarly, in last case, when g of s is here, if you want to take it to the front, you have to multiply with all the branches. So this is the way you can do the block diagram algebra. Now look here, there are some other examples here. So for example, combination and block cascaded, so you just have two blocks, you just need to multiply here. If there's a parallel block, you just add here. If you want to move this pick point to here, how you do it? You just multiply g, and here you need to divide because this is the feedback. So that your algebra is remains the same. Similarly, moving pick off point, take this block to the after the pick off point, then you have to multiply here. So similarly, last one, you want to take the summation back, so you have to do it for both cases. And lastly is that if you want to move this g to the front, then you have to divide here. And last one is if you can write this. So these are the same. So these algebra used to solve the block diagram. Now let's see one example, and then we will move to the lab quickly. So here, very simple, you just need to multiply, you take the feedback here, again you have to first solve this block, then multiply by this, and then take the feedback. Look here, you solve this in a feedback, then multiply by this, and then again feedback, you get this result. So this is the way you can easily solve. Last one is a bit tricky here. Look here, it's not obvious how you solve it, so I have to pick this point and take it here. This will make my life easy. When I make this point to this, I need a division here because this is not part of this output, so I need to divide here. So what I did, I just pick it and put here. So in that case, I divide here. So this make my life easier, and this is the cascade and the feedback. After that, then again cascade, then the feedback. Easily we can find the transfer function. Now this is the solution of this problem. You can do it very easily. Now there's another example, last one. Look here, this is the feedback path. You will solve it, then you take the what you say series combination, and then you take the feedback. You can easily solve it. And the last example, this one, look here, they are parallel and series. First of all, you have to solve this, and these all becomes so here G1, G2 are in series, H1, H2, H3 are in parallel, G1 is series with feedback configuration. So you just add these because this is H2 minus H1 minus H3, so I put here. After that, you take the feedback and you easily solve this problem. Now, after this example, let's come back to our lab here where we have to do it. Now in labs, this is the first example. We have a transfer function given to us. So we can solve this using Matlab commands. How we do that? We just use the feedback. In feedback, we have to put the feed forward transfer function GFS, then comma feedback transfer function, that is one. So this will give us the a reduced form. Similarly, for series, we use series combination with G1, G2. This will give you our result. After that, we have to solve the parallel one. Look here, this is the parallel one, so we use the command parallel, that will reduce it. So this is the first task that you have to do. For that task, you just assume any k. Okay, you can make this block diagram in a Simulink and give the input as a step and observe the output. Now after reduction using the series and parallel, do the same thing and do the block diagram of the reduced model with input step and look at the scope and compare. If you get the same result, so this means that your reduction is correct, otherwise you did something wrong. It's very simple here. This is the feedback, then multiply by k, then again the unit feedback. So you have to use commands, so you can easily find it. Now this is a bit difficult here, because look here, these two are parallel, then a feedback. So this is a tricky one. I left it to you to be carefully solve this one, because if you add it and then feedback, it will be wrong, because the output will be different. So you have to think about it and solve it by yourself. And then how you verify it, very easy. After reduce form, what you do, give the step input to the reduce form and also step input to the this block diagram that you can easily made in Simulink block using the Simulink library. So you can verify both results on same model file. So for example, this is a very simple parallel one, then you take the feedback, then you have to take the series and then feedback. So it's very easy to solve. So last one is that this is the transfer function. You have to take the unit feedback and solve this problem. So this is your lab. So the main what you have to do here is to how you solve this one. This is a tricky one. So hopefully you can do it using the algebra. Thank you. Let's stop.